All right, solving linear equations, okay? So now we're getting into solving these guys, and yeah, let's just start with number one. Problem number one. We have 4x plus 16 equals negative 4, okay? Now this is a linear equation. If you have any questions what a linear equation is, just watch my previous video, and it breaks it down in more detail. In this video, we're just going to be solving all kinds. We 11 problems we'll be solving. So after this video, we should all be experts at linear equations. All right. So when you're trying to solve something like this, again, what you want to do is you're always solving for your variable here. Okay? In this case, it's x. So what you're going to do is you're putting this guy in a box, and you can't move that box. So what you got to do is you got to move everything around it, okay? So this 16 here, this 16 is in the way. So in order to get rid of a positive 16, you have to subtract it. But if you subtract it to the left side, you have to do it to the right as well, because a positive 16 minus 16 is 0, okay? So we're going to be left with 4x equals this, which is negative 20, okay? And then when you have a number here, a constant times a variable here, this is multiplication, okay? Because they're close together, so they're kind of like friends. So the opposite of multiplication is division. So you're just going to divide this guy to both sides. On this side, you're left with an x, because those guys cancel, these 4s. Oops. So x is going to equal, now how many times does 4 go into 20? Negative 20 really, but 4 goes into 20 5 times, and it's going to be a negative 5 because we have this negative here, okay? So that is your very first one, not too bad, right? Alright, so on to our next problem. What does our next problem look like? Alright, we got negative 2x minus 5 equals 11, okay? So same concept as the first problem. So again, x. X is stationary. We do not want to move this x. You want to move the stuff around it away, okay? So we have this negative 5 here. So the opposite of negative 5 is a positive 5, okay? Because negative 5 plus 5 is 0. So we have this 11 plus 5 here. So we have negative 2x left over here equals 11 plus 5 is 16. Okay? Boom, 16. Now, what do we do now? We have negative 2x equals 16. Again, when these guys are together like this, you just divide out that constant there. So you're going to divide by a negative 2 on both sides. So the negatives and the 2's cancel. On this side, we're just left with x. And that's going to equal, how many times does 2 go into 16? 2 goes into 16, 8. But don't forget we have this negative here that we still want to carry down. Okay? And that's it. Not too bad. Alright. It will get harder, I promise. But nothing to worry about. Alright, so we have 3 over 4x minus 5 equals 2 over 3, okay? You will have to solve linear equations with fractions, okay? So we got to get comfortable with fractions, we got to get used to fractions, okay? So the first thing you want to look at is you want to look at all the bottoms here. Now this negative 5, it's really like divided by like an imaginary 1, okay? With that being said, you got to say, okay, you got to find what's called the common denominator, okay? What's the smallest number that a 3, a 1, and a 4 can go into, okay? In this case, it's going to be 12. So your common denominator between all these guys would be 12, okay? So what you're going to do is you're just going to multiply every single thing in this equation by 12. And I'll show you what it does. You're gonna love what it does, okay? Because it's gonna eliminate all the fractions. There'll be no fractions left, and everyone's gonna be, you know, have a smile on their face, okay? So what this guy does here when you multiply by 12 is it's gonna reduce, because remember, this 12 is divided by like an imaginary 1. So what you can do is you can do what's called cross-reducing, okay? Because 4 goes into 4 once. Here, I'll do this in a different color. 4 goes into 4 once, and 4 goes into 12 3 times, okay? This guy would just multiply. In this case, remember again, divided by 1, you can cross-reduce here because 3 goes into 3 once, and 3 goes into 12 4 times. Now, in the very next step, you're going to see what happens. Now, when you're multiplying fractions, you just multiply right across the tops and the bottoms. So 3 times 3 is 9, and we have an x here. The bottoms is just 1 times 1, which is 1, and we don't need to write, if it's divided by 1, we don't need to write that. Then we have minus 5 times 12 is 60, so we have negative 60 because of this minus here, and it's 5 times the 12 that we multiplied by. It's going to equal 2. You just multiply the tops here. 2 times 4 is 8, and it's divided by 1 times 1, which is 1, so we don't need to write that. So now we have an equation that just looked like the other problems. It started out ugly, now it looks pretty, okay? So again, you're just solving for x. So you're going to do the opposite of this guy. So you're going to add 60 over. Those guys are going to cancel out. You have 9x equals 60 plus 8 is 68. Now, remember these guys are together. You're just going to divide by that number there. You're going to divide by 9. Divide by 9. And, oh, getting kind of low here. X is going to equal 68 over 9. Now, whenever you have a fraction like that, make sure you can see this. Yeah, the camera's good. Okay. Whenever you have a fraction like that, you always want to see if it reduces. In this case, it won't reduce. So if the fractions do not reduce, you just leave it. That is your answer. Your answer is 68 over 9. It's ugly. Nonetheless, it's still an answer, okay? And that's that problem. On to the next one. Oh, I have a feeling as these problems get longer, I might need more space. If you're ever wondering why I never erased the name here, it's because there's a glare up here, and I don't really know how to fix that. So I kind of just leave this as my guide because there's no glare from here down. So that's why I do my math here, so the glare doesn't really interfere with that, in case you're wondering. All right, next problem. So we have 2x plus 6 equals 5x minus 4. Okay, now this is where it gets scary, right? Because we have an x over here, and we also have an x on this side. So we have an x on both sides, the left and the right. So what do you do with that? All right, what you do is you want to get all your x's on one side and all of your numbers on the other side, okay? So what I typically do is I look at the two x's here, and this is a 2x, this is a 5x. So I always like to move the smaller one to begin with, okay? So let me erase this guy right here. So let's move the smaller one over. And what I mean by that is since this is a positive 2x, you're going to subtract 2x to both sides. And always line it up. Since these are like terms, because they both have an x, line it up, okay? It'll make it much easier visually. Okay, so on this side we have 6 equals 5 minus 2 is going to be 3x, right? and then we got minus 4 here, okay? You see why we move this over? Psh, boom. Because now we just have one x. Now it's an equation just like all the other ones. So we got to get rid of the stuff around x. So we start off with this number here. So we're going to add a 4 to both sides. That cancels out. 6 plus 4 is 10 equals 3x. Okay? Again, we're still looking for x. We're looking for x, not 3x. So, divide both sides by 3, and we get x is equal to 10 over 3. Again, this guy doesn't reduce, so you put that guy in a box, and that's your answer. Okay? So again, recap. If there's an x on both sides, you want to get all the x's on one side and all the numbers on the other side, so then you can just solve it like, like we all know how to do. All right. Next guy. Okay. It's getting a little bit longer here. 13x minus 43 minus 9x equals 6x plus 37 plus 5x minus 66. All right, so this guy looks like a beast, right? It's not going to be that bad. Okay, so what you're going to do first when you have something so long like this is on each side you're going to look for things you can combine to condense this problem, okay? So you notice on the left side of the equal sign, we have this 13x here and this negative 9x. Those are like terms, okay? That being said, since they're like terms, you're going to be able to combine those. On your right side, you have a 6x and a 5x. Those are like terms. And you also have these numbers here that you can combine, okay? So let's just start doing that so this guy gets much smaller. 13x minus a 9x is going to be a 4x, okay? We still have this minus 43 here, equals now 6x plus 5x is going to be 11x. And whenever I combine stuff, I like to put a little check mark just to keep me organized. So now all we have left is this 37 minus 66, okay? And 37 minus 66 is going to be a negative 29, okay? So now, this problem, where it first looked all expanded and huge, now it's back down to a problem that we just did in the previous, it looks exactly like the previous problem we just did. You have an x on each side, you have a number on each side. Let's change that, okay? So again, you're going to want to move the smaller one over, okay? So you're going to subtract a 4x. Those guys will cancel out. You'll be left with negative 43 equals, that is going to be, it'll be 7x minus 29. Now we got this guy, okay? Again, we're solving for x. So you're going to want to add a 29 to both sides, so those guys cancel. So you're going to have 7x on your right side, and on your left side, you're going to have a negative 14, okay? And if you can't do that in your head, you can just go off to the side and just do it. You can do 43 minus 29, which is going to end up being 14. Just remember that since the negative 43 is much larger than the 29, it's going to be a negative number, okay? And I guess a little mind trick, how I did this in my head was 29 is really close to 30. Okay, so I just rounded up to a 30. Well, because it's a lot easier to do math with like round numbers like that. So 30 to 43 is going to be 13. And since I added one here, I'm going to have to do it here too. So 13, 14. Okay, so if that doesn't make sense, it's okay. Just do it off to the side. Now, our final step, divide by 7, and we got x is equal to, how many times does 7 go into 14? 2 times, but it's going to be a negative 2 because we got that negative on the 14, okay? And that's this problem here. Let's keep going. Whew. All right, we still got quite a bit to do. You guys having fun? Do you guys enjoy linear equations? Hope so. All right. So now we got 3 times 2x minus 5 plus 14 equals x plus 2 times 3 minus x plus 7, okay? Now, when you get like these things right here with these parentheses and you got a number out front, what you got to do is you're going to have to distribute, okay? You're going to have to distribute that. And I spoke about this distributing numbers in a previous video in case that doesn't make too much sense. But all you're going to ultimately do is you're just going to take this 3 and you're going to throw it to all those numbers and you're going to multiply them. Same thing with this 2, okay? So this 2 is going to go to that 3, and this 2 is going to go to that negative x. Okay, so that's our very first step. 3 times 2 is 6, and 6x, so we got that guy. 3 times a negative 5 is going to be negative 15, and then plus 14 equals, just carry down the x. Now we're going to throw this 2 through, pop, pop. 2 times 3 is a positive 6, and 2 times a negative x is going to be a negative 2x, and then just bring down this 7 here, okay? Now, combine like terms, okay? So what can we combine on this left side? On this left side, we can combine the negative 15 and 14, bring down the 6x. Negative 15 plus 14 is a negative 1. Now, on the right side, we can combine the things with the x's, and then we can combine the numbers, okay? X minus 2x is, so this is like, there's always an invisible 1 there, so it's really like 1x minus 2x, which will just be negative 1x, and we can just write that as a negative x. And then 6 plus 7 is going to be 13. Okay, now we just continue to solve it. So we have an x on each side, a number on each side. We just got to throw the x's on one side and throw the numbers on the other, okay? So in this case, I'm going to add an x to both sides, so those will cancel out. So on this side, 6x plus x is 7x minus 1 equals 13, okay? Again, keep in mind our goal, we're solving for x. So you're going to add the 1 over, and we have 7x equals 14. Now what's our last step? It's basically been the last step for every single problem. You guys know the answer, right? Correct, we're going to divide by 7. Divide by 7, those guys cancel out, and we're going to be left with x equals 7 goes into 14 2 times, and that is your answer, okay? Now one thing I want to note is no matter what class you're in, your teachers are really going to want organized work, and they're really going to want to find your answer real quick. They have tons of papers to grade, tons. I mean, imagine you got, even if you only have 3 classes to teach, each class has 30 students. I mean, you do the math, right? So it's going to be 90, right? So 90 tests, 90 homework assignments, 90. So the easier that you make it for the teacher, the more lenient he's going to be on his grading. I promise you, okay? Teachers have emotions too. They're in a bad mood, they're going to grade harder. You know, take my word for that, okay? Like that's $1 million tip right there. So make sure that your work is nice, neat, they can find the answer quickly, and they will give you a higher grade, okay? All right. Just don't tell your teachers I told you that. All right, let's do the next one. All right, this one. Yeah, this one's gonna be fun. So we got 3. I'm gonna try to write smaller because I'm not sure how much work this one's gonna take. 3 over 5x minus 2/3 equals 3 over 4x plus 5 over 6 plus 2x. All right. So remember that fractions problem we did? I think it was like the third problem we did. This is kind of like that one, only on steroids, right? Okay, do you recall the first step we did? Whenever, you see, the key here is whenever there's fractions involved, you just want to destroy them. Nobody likes fractions. I don't even like fractions, okay? No one likes fractions. But it doesn't mean you can't be comfortable with them. So the first thing we did was we found a common denominator, okay? Yeah, that is a 6, isn't it? All right. So our common denominator on this guy is going to be, I don't even know what it's going to be. Let's see. I believe it's going to be 30, okay? Because 6 goes into 30 5 times. 4 goes into 30. Let's see, does 4 go into 30? 4 does not go into 30, dang it. So what is the common denominator going to be? There's really no easy to figure out. Basically, you just have to ask yourself, I guess I should have prepared better, right, for this video. You have to say, what number can 6 go into, 4 go into, 3 go into, and 5 go into evenly? If you guys already know the answer, good job. Guess I'm getting kind of slow today. But I was making sure I wrote that down properly. All right, so let's see. I guess it's going to be 60, okay? Because 6 goes into 60. 4 goes into 60, right? 4 goes into 60 15 times. 6 goes into 60 10 times. 3 goes into 60 20 times. And 5 goes into 60 12 times, okay? So our common denominator is 60. I probably should have thought this problem through, okay? So hopefully that makes sense about the common denominator, okay? So what you have to do is you have to multiply every single term in this problem by 60. All of them, okay? But that's where the magic happens, okay? So it looks horrible, but we're going to fix that. So when you do that, remember, those are always going to reduce with that bottom number, assuming you did it properly, okay? So 5 goes into 5 once. Here, I'll do it with red. 5 goes into 5 once, and 5 goes into 60 12 times, okay? Reduces 3 with the 60. 3 goes into 3 once. 3 goes into 60 20 times. 4 goes into 4 1 time, and 4 goes into 60 15 times. 6 goes into 6 once, and 6 goes into 60 10 times. and then this last guy we're just going to multiply, okay? So now, in your next step, there should be no fractions, okay? That's the purpose of this. So, you just start multiplying stuff. 3 times 12 is going to be 36x. Don't forget your x. It's going to look sloppy, so make sure you take your time and really get everything down. Minus 2 times 20 is 40 equals, okay, 3 times 15 is going to be 45x plus 5 times 10 is 50 plus 2 times 60 is 120x, okay? And this is how it reduces from here to here. This is the main step. I know you can solve the rest of it, okay? It's just like a problem we've already done. The tricky part is this very first step. If you don't understand this first step now, don't watch the rest of it. Just rewind it a few minutes and rewatch it until you understand it, okay? That's very important, okay? Right there. But that's how you do it. So now, what do? We start combining stuff. On the left, we can't really combine anything. But on the right, we have a 45x and 120x. So we can combine those. So we have 36x minus 40 equals, this is going to be 165x plus 50. Okay, so 45 plus 120 is going to be 165. Then we just start subtracting stuff. So we're going to subtract the smaller guy, just like you've seen before. So negative 36x, negative 36x here. So I'm just going to go off to the side and do that. So we have 165 minus 36. You're going to subtract that. So you can't subtract 5 from 6. So you got to borrow. That becomes a 5. That's a 15. 15 minus 6 is 9. 5 minus 3 is 2. And that's 1. So we have 129. Okay? So we have negative 40 equals 129x plus 50. Alright, we're back. I apologize for that. Someone had walked into the center and I had to deal with a parent. But everything's cool now. So we're going to finish this problem right where we left off, okay? So we got this, right? So again, you're just solving for x. So you're going to subtract 50, subtract 50. That guy cancels. Negative 40 minus 50 is going to be negative 90. That's going to equal 129x. Okay? So then you're just going to divide by 129, divide by 129 on both sides. Okay, so we're going to have, let me erase this here. We're going to come up here. We're going to have x is equal to negative 90 over 129, okay? Now, you have to reduce this guy, okay? So, the first number that comes to my mind is 3, okay? 3 is going to go into 90, and 3 is going to go into 129. Now, let me show you a little trick so you can do that real quick in your head, okay? 90, okay, well, I'll just show you, okay? So with 90, all you do is you're going to add all of the numbers individually, the 9 and the 0. 9 plus 0 is equal to 9, okay? Does 3 go into 9? Yes, it does, so 3 must go into 90, okay? So let's try it for 129. You do 1 plus 2 plus 9 equals 1 plus 2 is 3. 3 plus 9 is 12. Does 3 go into 12? Yes, it does, so 3 must go into 129. Cool little trick, right? So that's just a fast way to check if it can reduce by 3. Doesn't tell us by how much though, okay? So, 90, we know 3 can go into 90 30 times, right? 30 times. Because, 30, 60, 90. Okay, that one's not too bad. The one that's going to be tricky is this one. So, again, I don't always advocate using a calculator because, your teacher won't always let you. So just do it longhand, okay? How many times does 3 go into 12? 4 times, right? So it's 12. Subtract that guy, we get 0. Bring down a 9. How many times does 3 go into 9? 3 times. Wasn't too bad, right? 43. So you just, boom, cross that out, 43 times. So 3 goes into 90 30 times, and 3 goes into 129 43 times. So we are ended up with negative 30. Don't forget we got a negative there. Divided by 43. And that, my friends, is the answer to this crazy guy here, okay? Again, this is probably the hardest problem we're going to do today. I mean, you can even see I had a little bit of trouble with it. Not really trouble, I just had to figure out the common denominator. That was tricky. But with that being said, if you need to review this problem again, just rewind the video, watch this problem again, and then continue the video, okay? We've got a couple more problems to do. Alright, so these ones are kind of cool because they're not too bad. You just got to understand the concept. So we got 8x plus 4 equals 8x plus 7, okay? So again, we got x's on both sides and numbers on both sides. So let's just subtract 8x from both sides, but watch what happens. That cancels off and that cancels off, okay? So we no longer have any x's. So we have 4 equals 7. Now you gotta look at this statement. This statement is just ridiculous. How can 4 equal 7? I mean, you can never have 4 slices of pizza doesn't equal 7 of the same size slices of pizza. So it doesn't make any sense. What that is telling us for this linear equation is there is no solution. There is no solution for that equation, okay? So you do have to be aware of that because that will pop up. All right. Let's try this next one. We have 7x plus 4 equals 7x plus 4. Same thing, and subtract 7x to both sides. Boom. In this case, they cancel out again, okay? And now we're left with 4 equals 4. Now, the last equation we had 4 equals 7, which didn't make any sense. Here, 4 does equal 4. That is a true statement. When you get a true statement like that, the answer is infinite, okay? There is an infinite number of solutions to this equation, okay? Meaning you can plug in any number for x and it will work. I mean, 1, 2, 3, 4, 100, a million, negative 10, negative 5. No matter what you plug into x, it will work. So you just write down infinite. There's an infinite number of solutions, and that's it. So those are the two special, quote-unquote, special cases that you do have to be aware of, okay? All right, on to our last topic, which is directly related to what we're doing. We have P equals A plus B plus 2C, but we want to solve for C, okay? Now, these ones do kind of trip up students sometimes, but don't worry. Remember, A, B, and P, they're just numbers, so you treat them like numbers, okay? We're solving for C, so again, you want to imagine imaginary box around C, but that box is so heavy that Thor can't even pick it up, right? And he's a pretty buff guy. So that being said, you gotta move everything else away from it since this box can't move. So what you're gonna do is you're gonna subtract A and you're gonna minus B. You know, I'm gonna do this all in one step, okay? So you're gonna subtract A onto the side and subtract B. So on our right side, our A's and our B's cancel. And what do we have on our left? On our left, we're just gonna have P, this P here, minus A minus B equals to C. The reason it's P minus A minus B is because none of these are like terms, so none of them can combine. They're all different letters, they're all different variables, so none of them can combine, okay? So then, to finish solving for C, divide by 2, and you're just going to divide this whole thing by 2. So C is going to equal P minus A minus B all over 2. And that is your final answer. I don't know why I keep writing crooked like this. I don't know, something's wrong with me, I guess. But that is your answer, okay? So you're just simply solving for C as if these are all just normal numbers, okay? All right, one last problem. Okay, so we have S equals 2 pi times R times H. And we want to solve for R. What does R equal, okay? In this case, remember, these are all multiplication here. These are all together. There's no symbols in between them. When there's no symbols or anything like that, it's all multiplication. 2 times pi, this is the pi symbol, if you haven't seen that before. 2 times pi times R times H. So again, you're going to put your R in an imaginary box, but again, that box is so heavy you can't move it, so you got to move everything else. If this is all multiplication, what's the opposite of multiplication? Division. So what you're going to do is you're going to divide both sides by everything but that R. Okay? And you're going to see what happens. So the 2's cancel, the pi's cancel, the h's cancel, and you're just left with R. Okay? So our final answer is just going to be R equals S divided by 2 pi H. And that is the answer when you're solving for R. Okay? So I hope you enjoyed this video. Please subscribe and leave a comment below how you can improve these videos, or if you liked it, share it with your friends. And let's make this an extremely educated community. I'll see you guys in the next video.